So here we are on exam 3. This is the information that you will be allowed to have. So you can have this on the sheet. There's also the chalkboard that has the trig identities, which you won't need for this exam, but that will also be there. Okay, so first thing, which of the trig functions are positive in which quadrants? So an easy way to remember this, all students take calculus. In the first quadrant, they all are. In the second quadrant, only sine is positive. In the third quadrant, only tan is positive. And in the fourth quadrant, only cosine is positive. So that's one thing to know, or you don't really have to know, but you should really just know it. It'll make your life easier. Law of cosines. Remember that this isn't the only one. You could also solve for a squared equals b squared plus c squared minus 2bc cosine theta a, or b squared equals a squared plus c squared minus 2ac cosine theta b. So any one of those will work depending on which angle you know and which side you're trying to solve for. We've got our law of sines. You might have learned them all flipped upside down. That's fine too. So sine theta a over a equals sine theta b over b equals sine theta c over c. Those are all equally valid. And then when we talk about significant digits, this is sort of the guideline to use. So if your angle is measured to the nearest degree, then like, let's say, your angle is 57 degrees. When you do sine of 57 degrees, you'll want to write it down, or you'll end up rounding it to two significant digits. If it was 57.0 degrees, then you would write it to three significant digits. And usually it tops out at 4. So if it's anything more precise than to the 100th of a degree, just use 4 significant digits in your final answer. Okay, so that's the front page. First question. What is the cosine of 78 degrees? So this is just whether or not you know how to plug this into your calculator. So when you use your calculator, just make sure, let me see if I have my small little scientific calculator here that I bought at the dollar store. So I'm just going to illustrate with this. Your calculator may be slightly different, but it's important that you know whether you're in degrees or radians. So we can see here that we are in degrees. So I'm going to type in 78 cosine, and it tells me that the cosine of 78 degrees is 0.2079. Again, according to the little helpful hints page that I gave you, if your angle is measured to the nearest degree, then you're going to use 2 significant digits. So we're going to call this 0.21. Next, what is the cosecant of 1.09 radians? Well, that's 1 over the sine of 1.09 radians. Please bear with me. I am starting to lose steam. Okay, so we need to make sure that we change to radians. So now our calculator is measuring angles in radians. So we've got 1.09. Oh, that's not right. we take the sine of that, and then, do I have a reciprocal button? I thought I did. I guess I don't, so let me back up. I'm going to do 1 divided by parentheses 1.09 sine, close parentheses. Okay, so this is going to be, because this angle is accurate to 3 significant digits, again with radians, we're just going to use the number of significant digits that were given in the radian measure. We're going to round this to 1.13. Okay, so next, if tan is positive and sine is negative, which quadrant is theta? So if tan is positive in quadrants 1 and quadrants 3. Sine is negative in quadrants 3 and 4. So we want the quadrant in which both of these are true. That would be quadrant 3. Next question is the same thing. So cotangent is the reciprocal of tangent. So wherever tangent is positive, cotan is positive. Wherever tan is negative, cotan is negative. So cotan is negative the same places where tan is negative. That would be quadrants 2 and 4. And cosine is negative in quadrants 2 and 3. So if both of these things are true, then our angle must be in quadrant 2, because that's the only one that appears in both options. Okay, number 5. Find all values for theta between 0 and 360 if cosine theta is equal to 0.4519. So first of all, if we do cos inverse of cos theta on both sides, or cos inverse on both sides, so cos inverse of 0.4519, and again, because we know theta is in degrees, we need to make sure that our calculator is on the correct setting. So we're gonna when we take the inverse cosine of cosine, we're just left with theta, and when we take the inverse cosine of 0.4519, we're going to get, so I said round your answer to 2 decimal places, so 63.13 degrees. Okay, well, cosine is a positive number in 2 places, both in quadrant 1, which this is, 63 degrees is in quadrant 1, but cosine is also positive in quadrant 4. So we have to find the quadrant 4 angle that's going to have the same cosine value. What I like to do is I like to draw a little picture. That always helps me. If you have some other way that you remember it, that's great. But I always like drawing in the reference angle. Okay, so here's theta, right? Theta equals 63.13 degrees. We're going to draw the mirror image of that angle in quadrant 4, because again, that's the other place where cosine is a positive value. So we draw the mirror image here. Right, there's our theta again. So this is 63.13 degrees. But really the angle that we measure is this one here. So I'm going to call this now theta 1. So theta 1 is 63.13 degrees. theta 2 is going to be 360 minus 63.13 degrees. And that's going to give us 296.87 degrees. Okay. Next, secant theta is 2.28. So we've got 1 over cosine theta equals 2.28. So we can take the reciprocal of both sides. We can say cosine of theta is equal to 1 over 2.28. So then we take the cos inverse of both sides. So that tells us that theta, and I'm going to call this again theta 1, because there are two values of theta. So theta 1 is the cos inverse of 1 over 2.28. Okay, so that's going to be 63.99 degrees. And again, we're looking at cosine because secant and cosine are just reciprocals of each other. So secant is positive wherever cosine is positive. So again, that's quadrants 1 and 4. So it's almost exactly the same thing. So 63.99 degrees. This mirror image is going to be right here. So we're measuring up to there. Theta 2. 360 minus 63.99. That's going to be 296.01 degrees. So it's all about realizing whether you have a positive or a negative number, first of all. And then where is that trig function positive, which quadrants, or where is it negative, which quadrants. You'll take the inverse to find one of the angles, and then you'll have to use the mirror image to find the other angle. Okay, next. Assume theta is an angle in standard position whose terminal side contains the point minus 410. So I'm counting by 2's here. So minus 410. There's our angle. So here's theta. So what do we know? We know that this is 10. This is 4. You can't really see that, I guess. That's 4. I don't know if you still can see that, but that's a 4. And to get the hypotenuse, we can use the Pythagorean theorem. So this side is going to be the square root of 10 squared plus 4 squared, so that's root 116. 116 breaks down into 4 and 24. No, that's wrong. 4 and 29. Okay. So this is essentially going to be 2 root 29. So that's the length of the hypotenuse. Okay. So let's remember SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So it turns out that if we look at this reference angle, the sine of this reference angle is the same thing as the sine of theta, and the cosine of the reference angle is the same thing as the cosine of theta. So this is nice, and same thing for tan. So all we have to do is just use this reference angle instead. So the sine of theta, opposite over hypotenuse, so that's going to be 10 over 2 root 29. So that's going to reduce down to 5 over root 29. Cosine of theta, remember this is in quadrant 2, so I am going to keep the negative there. So it's going to be negative 4 over 2 root 29. That's going to reduce down to negative 2 over root 29. And tan is opposite over adjacent, so 10 over negative 4, which is going to reduce down to negative 5/2. And then the rest are just reciprocals. So cosecant of theta is the reciprocal of sine, so that's root 29 over 5. Secant is the reciprocal of cosine, so that's negative root 29 over 2. And cotan is the reciprocal of tan, so that's going to be negative 2/5. Okay, next, resolve the following vector into its x and y components. So what do we know? We know that x is equal to the absolute value of v times the cosine of theta, and y is equal to, it's not really an absolute value, it's a norm, or another word for it is, vocabulary is escaping me right now. We could call it the length. We could call it, oh, this is driving me bonkers. I'm sorry. We'll just call it an absolute value. It's a distance. It's a measurement. So it's basically the length of v times cosine of theta, or the length of v times the sine of theta. So this is going to be 25.0 cosine of 76.0 degrees. This is going to be 25.0 sine of 76.0 degrees. So what do we get? Again, this has 3 significant digits. This has 3 significant digits, or again, it's it's measured to the 10th place, so we'll use 3 significant digits. So this is going to end up being 6.05. And this ends up being 24.3. So if we were to write it in vector notation, 6.05, comma 24.3, like that. Okay. Next. We're given some information about a circle, and we're asked to find other bits of information. So, arc length. We know that arc length is equal to theta times r. So this one's pretty easy, nice little plug and chug. We've got 1.05 times 9.22, and that is going to be, after we're done rounding, is going to be 9.68. It's 9.681, but we're only rounding to 3 significant digits. And since our radius is in meters, our arc length is also going to be in meters. Okay, and then to find the area of a sector, so let's say 125 degrees is somewhere like right about here. So we're looking for the area of this piece of the circle. basically what we want to do is we want to create a fraction and figure out what fraction of the entire circle that is. So the area is going to be 125.529 over, and we can make this as precise as we want because we know it's exact, 360.000. So that's how much of the circle is taken up by that piece, times the area of the circle, which is pi times 16.11 squared. So what have we got? We've got so this is what I got after I divided 125.529 by 360. Now I'm going to multiply by, in parentheses, 16.11 squared. And then I'm going to multiply by pi. Okay, so what have we got? We've got 284.3, again, because this only has 4 significant digits, so that's what we're going to go with in our answer. And our units are, since our radius was in feet, this is going to be square feet for the area. So again, if you're given the angle, just find out what fraction of the full circle that is by putting it over 360, and then multiply it by the area of the whole circle. Okay, moving on. Through how many radians does the wheel of a car rotate in 2.25 rotations? So if we think about it, once all the way around the circle is 2 pi radians. So 2 pi radians equals 1 rotation. So we can just do a little bit of dimensional analysis here. 2.25 rotations times 2 pi radians per 1 rotation. The units of rotations cancel out. So we've got 2.25 times 2 pi. So I'm just going to call this 4.5 pi radians. And you can give me a decimal number if you want, or you can just leave it with pi, that's fine. Okay. Next, 2 forces of 88 newtons and 45 newtons act on an object at right angles. So find the magnitude of the resultant and the angle it makes with the smaller force. So usually if I'm saying find the angle it makes with the smaller force, it's easier to put the smaller force along the x-axis. If I say find the angle it makes with the larger force, put the larger force along the x-axis. Usually it's easier to measure from the x-axis because that's how we're used to measuring angles anyway. So I'm going to put my bigger force of 88 newtons along the y-axis. I'm going to put my smaller force of 45 newtons along the x-axis. Okay, so how do we figure out the resultant vector? We're going to use the parallelogram rule. So we add tip to tail. I'm going to slide this vector over and put it here. And then if we draw the resultant, it's going to be the diagonal of this parallelogram. So here's the resultant. I'm going to just call it R. And here's theta. So, oh, the word I was looking for before when I couldn't figure it out was magnitude. So this, it's I called it an absolute value before. You may hear it called a norm. It's also called the magnitude of the vector. So that's what we mean when we put it in 2 sets of absolute values. That's also another way to write magnitude. Okay. Okay, so what are we looking for? We're looking for the magnitude of r. So the magnitude of r is, again, we're going to just use the Pythagorean theorem. So it's the square root of 45 squared plus 88 squared. And since I only give you two significant digits, that was what we have to round to. So the magnitude is going to be 99 newtons. Okay, and then how do we figure out the angle? Well, we know the opposite side and the adjacent side. So we can say tan theta is equal to 88 over 45. So then theta is equal to the inverse tan of 88 over 45. And the inverse tan of that is 62.91. But again, since I only gave you two significant digits, we're going to call that 63 degrees. Okay. So here we have a vector that's broken down into its x and its y components. So find the magnitude of v. So vx is 88.51 and vy is 16.77. So here's the resultant. So here's v. So the magnitude of v, again, is just the Pythagorean theorem. So the square root of 88.51 squared plus 16.77 squared. And since I've given you four significant digits, we round to four significant digits, so that's going to be 90.08. And what is the angle that theta that v makes with the horizontal? So again, we'll use tan. So theta is equal to tan inverse of 16.77 over 88.51. And rounding to four significant digits, we're going to get 10.73 degrees. Okay. Next, now our forces are not at right angles to each other. They're at some other angle to each other. So the angle between two forces of 18 newtons and 26 newtons. So I'm just going to put 18 along the x-axis. And let's make another force. It's a little bit stronger. That's going to be 18.0 and 26.0. And the angle between them is 63.0 degrees. Okay, so now parallelogram rule, right? Draw ourselves a parallelogram. And the top can be a little straighter. All right, so we draw ourselves a parallelogram, and we draw the diagonal, and that's the resultant vector. Okay, well, what we're going to need to do is, in order to use the Pythagorean theorem and find out the magnitude, is we are going to have to figure out what these sides are. So Sorry, I'm just fixing my picture a teeny little bit to make it like this so that when I draw this down, it won't be confusing. Okay. So, first of all, we need to figure out the x and y components for both vectors. So, this vector, right, this one with a magnitude of 18, we can write this as 18.0, comma 0.00. So it's 18 purely in the x direction and none in the y. So that's this point here. What about this point here? So how do we get that? Well, here's 63 degrees. Here's the resultant vector. We can look at this smaller right triangle first. And so we know that the x component is going to be 26.0 times the cosine of 63.0 degrees, and the y component is going to be 26.0 times the sine of 63 degrees. Okay, so rounding to 3 significant digits, that's going to be 11.8 for our x. And 23.2 for our y. Now, to get the resultant vector, we're going to be taking our original vector and adding the new one to it. So we're basically just adding the components together to get to this spot. So we've got 29.8, comma 23.2. So that's how you do one of these problems, where if your vector is separated by something other than, if your two vectors are separated by something other than 90 degrees, then you want to break them down into components, add the components together, and that will give you the components of your new vector. And now, if we call this r, the magnitude of r is going to be the square root of 29.8 squared plus 23.2 squared. So now we're using this bigger triangle. We know that this entire distance is 29.8, this distance is 23.2, and we can use the Pythagorean theorem to find the magnitude. And again, using 3 significant digits, that's going to give us 37.8 newtons. Okay, I'm going to stop the recording here, and I'm going to make a part 2 of this.